Today we are learning second chapter, work, energy and power. So already we learned about the work. So work is said to be done when a force is applied and it should move some distance. So distance is expressed in the form of yes. So we know that example so many are there. If a ball is there, if you want to move that ball, you want to apply some force so that it moves some distance. So this force and distance both, okay, force into distance will make the work. Work is said to be done when a force is applied and then the body is going to move some distance, then we say that work is said to be done. W is equals to F into, yes, here two factors, force and distance, both are two important factors. Suppose W1 is the work, F1 into S, and W2 is the work, F2 into S, both the same distance. If F1 is greater than F2, what is the meaning of that? Work 2, W1 is greater than W2. As same like that, if distance is also distance is also more, we can say that work is more. So work depends upon two factors. What is that? One is force and distance. Okay, now force will be measured in newtons and distance is measured in meters. Newton, meter, we can take it as a joule. So work, units of work is work in SI system. SI unit is joule. So work, not in that work is a scalar quantity. Work is scalar quantity. What is scalar? You know. Work is scalar quantity. We will find out why it is a scalar quantity. Work is a scalar quantity. This scalar quantity, why we are saying this is scalar quantity? Because sometimes the applied force, body doesn't move towards the applied force direction. If it is not moving in the force direction, suppose example a pitch roller, if you take a pitch roller as an example, so your pitch roller will be like this and you will have that to hold and move, but we are moving in this direction, the wheel will rotate in this direction. So force is in this direction, wheel is in this direction. So it is not along the direction of a force, it is in the circular motion. So pitch roller we can take it as example of a scalar quantity of a work. So many examples we can take it for a scalar quantity. So pitch roller is also an example for work is a scalar quantity. And work can be, work measurements we said, work having F into S cos theta, we can write it like this, and work is also F cos theta. Yes. So these two equations, when force and distance are making some angle, then we can use this formula F cos theta. How we are going to be define that F cos theta. So when a force is along the direction of a displacement, otherwise force is, the displacement is along the direction of a force, we can write these two equations. I will explain that in this force and displacement. We already learned about work, and now there is a right angle triangle. Okay, otherwise in this direction I will take it. Now this is A, B, C. So body, if you want to move, you are applying the force in this direction, body is moving in this direction, and here this is displacement and this is the force we are applying. Now this is, when force is applying in this direction but the displacement is in this direction, this is making an angle theta. If you are taking a cos theta is equals to, cos theta is equals to what we can write it here, cos theta is equal to adjacent by hypotenuse. We know that AB is equals to AC is equals to, what is AC actually? This is the displacement we are taking. So yes, so AB is equals to, we can do it as S cos theta. So this S cos theta, AB is equals to, we know that if W is equals to F into distance is what? AB force and distance is making one angle, that is nothing but S cos theta. This is force, displacement along the force. Work is done when displacement along the force. Okay, displacement along the force, we can write it this W is equals to F into S cos theta. So this is the formula when the displacement is along the force. W is equals to F into S, we know. Actually, how to write W is equals to F cos theta? F into S. When it is making an angle between force and displacement, F into S cos theta will write when work is done in some angles. So W is equals to F cos theta. Actually, force is in this direction, but the displacement is, the body is moving in this direction. These two are making an angle theta. We can write cos theta is equals to, so AB adjacent by hypotenuse. We know that cos theta is equals to AB by S. AC is nothing but displacement S. So AB is equals to S cos theta. We know that W is equals to F into S, but displacement is in the form of, this is the displacement actually. This time the body moved. From here to here the body moved. W is equals to F into S cos theta, but it is in the form of some angle. Okay, this distance is in the form of some angle. We are writing W is equals to F into S cos theta. Theta value we are going to get from here. This is displacement along the direction of a force. Displacement, this is displacement, this is the direction of a force. Okay, this is one. W is equals to F into S cos theta. This is one expression. One more is W is equals to F cos theta into S. This is force along the displacement. There is a force along the direction of a displacement this one. Here work is equals to force along the direction of displacement. See here, this is the force we are applying in the direction of displacement. Actually force should be in this direction. So force along the direction of displacement into displacement. What is this into displacement? Two displacements we got. This is the force along the direction of displacement is this. Again here to here is one displacement. Here W is equals to, here I am taking it as a N. This is one right angle triangle. It is looking like one right angle triangle. This is A. This is P. From triangle PNA, we can write. We are doing force along the displacement. Force along this displacement we are doing now. How to express this? W is equal to F cos theta into S. Now we know that from this triangle PNA, cos theta is equals to adjacent by hypotenuse. Now PA is equals to, okay, so NA is equals to, what we have right? NA is equals to PA cos theta. What is PA here? What is PA is? F. Therefore, NA is equals to F cos theta. You understand why we wrote here F cos theta now? NA is equals to F cos theta. Now this NA, what actually work is equals to NA into AC. Why we are writing NA into AC? The direction, work is done along the direction of displacement. That means force is applied along the direction of displacement. This is NA into AC. What we are doing? What is NA here? F cos theta. F cos theta into, again AC, this AC is what? AC is what? Yes. Therefore, this can be F cos theta into S. W is equals to F cos theta into S. This is how we will write. Special cases of work here. So, case 1, displacement in the direction of force. Therefore, theta is equal to displacement. Suppose a ball is falling down. So, here direction along the displacement. So, here the theta is equals to 0, angle is 0. Therefore, cos 0. You know that cos 0 is equals 1. Therefore, W is equals to F into yes, force and displacement we can keep it and we can find out the how much work is done. This is, but it is in the form of gravity. F is m into g. F is, we know that F is equals to mg, that is mass of a body, and this is the this is falling. This force is created due to the gravity because of the mass. So freely falling body will have m into g into s. We can write it this m into g into this distance, we can take it as h, mgh. So W is equals to mgh. The freely falling body will done the work in the form of mgh. This is the case 1. Now case 2, we have the case 2, theta is equals to 90 degrees. Example, we can take it as Cooley. When Cooley is taking the weight on his head, okay. Now he is moving in this direction and force will be in this direction. The force is normal to the displacement. Force is normal to the displacement. That is nothing but W. Actually, W is work done mgh, because mass is raised against the gravity to a certain height. Actually, Cooley is doing work in the form of W is equals to mgh, whereas force and displacement both are perpendicular to each other. So theta is equals to 90, cos 90 is equals to 0. Therefore, W is equals to F into S cos theta. If you are taking, W is equals to 0 because cos theta is equals to 0. This is the second case. Not only here, a revolving object is also want to move away from here. This is the displacement. Revolving object always want to move away from the circular path, and but the force is towards the center. These two also perpendicular to each other. Therefore, revolving bodies work is also 0. Body which is in circular motion, its work is 0. Okay, 3, theta is equals to 180. Freely falling body we have seen. Now you can take a body and throw it up. It is opposite direction. Okay, work is done in the form of opposite direction. That will come under theta is equals to 180, because F cos theta into S if you take. Now F into 180, cos 180 is minus 1 into S, which is nothing but minus F into S. Work is done in the form of negative. Okay, not only that, if you take a ball, this rolling ball, if you want to stop, you have to apply the opposite force. This opposite force is nothing but negative of the force. So this negative force will done the work in the opposite direction. So therefore work is in negative. So theta is equals to 180 degrees. Example, a body which is thrown to upwards nothing but against the gravity. If you throw, the work done in the form of negative. So we have 3 cases. Theta is equals to 0. And theta is equals to 90 degrees and theta is equals to 180 degrees. Here along the direction of a force, here the perpendicular direction, both force and displacement, the work is done is here 0, and theta is equals to 180, the work will be in the form of negative. So it is positive, it is 0, it is negative. Work will have 3 cases. This is the special cases of work. Power is nothing but rate of doing work. Rate of doing work. We know that power can be expressed as W by T, nothing but rate of doing work. Suppose, example, a coolie A and coolie B, both are there. Both are doing the same work, but he completed in 1 minute and he completed the same work in 2 minutes. Then whose power is more here? Coolie A is having the double power. He utilized the double power to do the work in less time. So less time will have more power. So power and time is inversely proportional here. Therefore we can say that rate of doing work is called power. Power units. Power is equals to, this is work can be measured in joule and time will be measured in seconds. So joule per second is nothing but watt. So units of power is nothing but, what is that? Watts. Unit of power is watts. You know that in CGS it is ergs per second. So 1 joule is equals to 10 to the power of 7 erg per second. This is in the CGS unit, we can say erg per second. We have many, we can with this rate of power is having so many units like this: megawatts, gigawatts, kilowatts, microwatts, sorry, milliwatts, microwatts. Gigawatts is 10 to the power of 9 watts, and mega is 10 to the power of 6 watts, and kilo is 10 to the power of 3 watts. Milli is 10 to the power of minus 3 watts. Micro is nothing but 10 to the power of 6 watts. Like this we can use it. So different units we can, watts can be used for more watts, we can use the bigger units, and smaller watts we can use the smaller units here. And we have that horsepower. 1 horsepower is equal to 746 watts. This watts can be used in 746 watts. It is also can be 0.746 kilowatts. This power is also used in our electricity. When electricity chapter comes, we will know about that power, how we are going to define their power.